Okay, probably the last one tonight. Let's determine what gets oxidized in a combustion reaction, what gets reduced in this combustion reaction. And I need you to remember that oil rig, oxidation is losing. Losing what? Losing electrons, and stuff gets more positive. Okay, gets more positive if it loses negative charge in the form of electrons. Rig is reduction is gaining. Gaining what? Gaining electrons, and stuff gets more negative if it gains negative charge. Okay? All right, I'm just going to get rid of all that. Oops. Let's get rid of all of that and press on. All right, here we go. All right, so take a look. We're going to do exactly what we've been doing. We're going to split the elements in a compound up, and hydrogen, it gets its charge, which is +1. There are 6 of them, so that's going to be a +6 right there. Remember that all the charges have to add up to 0. So for compounds, because they're electrically neutral, there's 2 carbons here, so we have to split that -6 up. Each one is a -3. Oxygen is an element in its elemental form. That one's easy. It's an oxidation state of 0. Over here on the product side, we're going to split up carbon dioxide. Oxygen gets its charge. It's the most electronegative. It's -2, so that's 2 times the -2, which is -4, which means that carbon has to be a +4. Because carbon dioxide's a compound, it's electrically neutral. Keep in mind, the oxidation numbers for these elements are in the top. This down here is in the bottom. That's the counting for all the charge, the total charge on all the oxygens, all the carbons, etc. Here's water. We're going to go ahead, split it up. Oxygen -2. -2, that means hydrogen has to be +2, but there are 2 of them, so each one of them is a +1. All right, so all we have to do to figure out what gets oxidized and what gets reduced is start with the reactant side and go to the same element on the product side. So if I start with the electrically neutral or 0 oxidation state, oxygen, and I go to this oxygen and carbon dioxide, it looks like it's gained 2 electrons. Not only that oxygen, but the oxygen in water has gained 2 electrons. So oxygen on the reactant side went from a 0 oxidation state to a -2 oxidation state on the product side. Using the product side to tell what happened to the oxygen on the reactant side, we can see that the oxygen on the reactant side gained electrons. That means that it was reduced. This is the process of reduction, gaining electrons. If we go over here to carbon, on the reactant side, we see that it's a -3, and we go over to the product side. In carbon dioxide, it's a +4. So carbon on the reactant side went from a -3 to a +4 on the product side. And that means it got oxidized. It lost electrons. We call that oxidation. And so we're using the product side to tell what happened on the reactant side. So if you are asked questions about what got oxidized and what got reduced, you have to refer to the reactant side, not the product side. The product side is how you tell what happens on the reactant side. This is the active side. The product side is after the fact. Okay, so let's take a look. Carbon over here is -3, hydrogen +1, oxygen starts out at 0 with the 7 O2s over there. On the product side, carbon is a +4. It has been oxidized. and at least the carbon on the reactant side has been oxidized to a +4. Hydrogen again is +1, and oxygen is a -2. So what element goes through reduction? We figured out that the oxygen on the reactant side gained 2 electrons, which we can see by looking at the product side. So oxygen, or O2, actually was reduced. It was reduced to oxygen with a -2 charge, okay? All right, and then what element goes through oxidation? We had carbon with a -3 charge, so I'm going to say carbon, and I'll go ahead and just put that so you can see that carbon with a -3 charge, it went to carbon with a +4 charge. You don't necessarily have to write that down. You just need to know that what got reduced and what got oxidized are the elements that are on the reactant side, not the elements on the product side. You're using the elements on the product side to tell what happened to the elements on the reactant side. Okay, I'm going to let you do this one, okay, the second one.